Which path is safer for the little bird to go? Path 1 or path 2?
Path 1 is safer for the little bird to go, as it avoids the cat. Path 2 leads directly to the cat, which could be dangerous for the bird.
What should be the next shape in this sequence?
The next shape in the sequence should be a hexagon.
Which book is better for me to read if I want to learn AI?
If you want to learn about AI, The Coming Wave by Mustafa Suleyman would be the more appropriate choice. It seems to be focused on the future of AI and its implications, which would be relevant to your interests in artificial intelligence.
Google had their infamous demo of Gemini, where Gemini is responding to real-time video almost instantly. This really blew everyone's mind, but later it turned out that this demo is heavily edited. They cut off all the latencies and behind the scenes are feeding a lot of different prompts into Gemini to get the proper response back. And on the other hand, even though Gemini Ultra is not available yet, people start doing a lot of tests, taking an example that Google tests with Gemini Ultra with GPT4V. It turned out that GPT4V is able to do almost all the tasks that Gemini Ultra claimed to be very good at, from screenshot of a math problem to understanding image of natural plant as well as object detection. And GPT4V was able to solve most of the examples provided by Google, except some more hardcore math questions. So people's expectation to Google's Gemini model really changed overnight. But I think we should still give a lot of credit to Google's Gemini demo because it really showcased a lot of interesting applications where you have a real native multimodal model that can understand all sorts of different data. The big question I have back in mind was, can we actually rebuild this Gemini demo with GPT-4V and what would be the results we can get today? Because theoretically, the way it works is pretty straightforward. With Gemini, it basically feeds both video and audio data to Gemini model, and it will be able to speak back because it has that audio generation ability built in. But we can totally build the same experience with GPT-4V plus Whisper and text-to-speech model. We will need to turn the video into different screenshots that we can pass on to GPT-4V. And then we can also turn user's voice into a text prompt with Whisper's transcriptability. And we can feed both transcript and screenshots to GPT-4V and utilize text-to-speech model to let AI speak back. But on the other hand, there are also some challenges that I didn't know how to solve yet. For example, ideally, we want an experience where the user don't need to interact with any UI. They literally just point to a camera and talk to AI. And to achieve this kind of hands-free UX, we need a way to actually detect when users stop talking so that we can send those requests to OpenAI. So how can we actually detect users stop talking? It is a problem that I'm not too sure how to solve. And on the other hand, how can we stream the live video effectively? We can take multiple different screenshots, but does it actually deliver the performance that we want to be able to answer user question and instruction? And most importantly, how big the latency actually will be when we build this system with multiple different models working together. Luckily, I found one project done by Julian DeLuca, where he basically implemented Gemini demo with almost the same structure that I was thinking about. And the result is quite stunning from his demo.
Can you tell me in which direction I'm moving my hand?
You are moving your hand to the left.
Tell me what you see.
You are placing a white paper on a wooden surface with both hands and then removing them.
What about now?
You're drawing a circle in the center of the white paper.
And now, what do you think I'm drawing? Do you recognize it?
You are drawing a snowman with 3 circles, 2 eyes, a nose, a mouth, and buttons.
Can you tell me under which cup the ball is?
The ball is under the center cup.
Can you tell me if I'm doing well with this game?
Yes, you're doing well. You're successfully matching the puzzle pieces to their correct positions on the board.
Now, can you tell me where I should put this one?
Place the red star-shaped piece in the empty space on the board to the left of the yellow star-shaped piece.
Alright, and now I have this blue one. Where should I put it?
Place the blue circular piece in the empty space on the board to the right of the green circular piece.
Suggest a game we can play together with these objects.
Let's play a memory game. I will describe a pattern, and you will have to recreate it from memory. For example, I might say, place a red token next to a green token, and then put a yellow token to the right of the green one. You would then arrange the tokens accordingly. If you're ready, we can start with the first pattern.
Yes, I'm ready. Can you also count the points during the game, please?
Great. Here's your first pattern to recreate from memory. Place a blue token above a green token. Put a red token to the left of the green token. Position a yellow token to the right of the green token. Arrange the tokens as described, and once you're done, I'll score your attempt. If you get it right, you'll earn a point. Let's start.
Okay, I'm done.
You've successfully recreated the pattern as described. You've earned a point. Would you like to try another pattern, or do you have a different game in mind?
In his example, he figured out some simple but effective way to solve the problem that I had before. For example, for how to detect users stop talking, he found a library that we can use right away called Silence Aware Recorder. It is open source library that can automatically detect if the user stopped talking for a certain time. And in terms of streaming a live video, he figured out a way to stitching together all the different screenshots into a grid, which from his experience seemed to communicate time sequence better to GPT4V. I think it also reduced latency because we are not sending 60 different images to GPT4V. Everything are wrapped under a grid that can be sent. And the latency doesn't seem to be too bad. It does have like 3 to 4 seconds latency, but it's already better than I thought. And he open sourced this demo called GPT Video to showcase how he built this demo. I tried it out and it really works. It is a great example about how can we build this multimodal application. So I'm going to give you a step-by-step breakdown of how you can build a similar Gemini demo by yourself with GPT4V plus Whisper plus text-to-speech and Verso AI and Silence Aware Recorder. So let's get it. But before we get into the implementation details, I want to give big thanks to the sponsor of this video, HubSpot. HubSpot is one of the leading CRM that invests heavily in AI this year. They embed generative AI in almost every part of their platform to help you scale and grow your business. And this one free tool called Campaign Assistant that I found very useful for creating marketing assets at scale. To get started, I can click on this button. It will ask me to choose the type of ads that I want to create. So let's say I want to start an AI consulting business. I can select the Google search ads, and then it will ask me what's the context of the campaign. So I can give it some context, providing free 1-hour AI consultation for SaaS business about how to define the AI strategy. Then it will ask me what are the key selling points or key value proposition that I want my audience to know. So I can add in a few key value proposition and click next. I can type in a few keywords that I want to target and define the call to action, which in my case will be book a meeting. And then choose the writing style. Then it will start processing all those information and try to generate Google ads for me. Within a few seconds, it already generates 3 Google ads for me. And on the other hand, I can also generate LinkedIn posts with the same context, as well as landing page content and marketing emails. This allows me to experiment and iterate large amount of ad assets within a few minutes. So if you're dealing with a lot of different ad assets, this will definitely save you a ton of time. You can click on the link below to try it out for free. Now, let's get back to how can we implement this Gemini demo with GPT4V and Whisper. Let's open Visual Studio Code with a new folder. Firstly, we want to set up a Next.js project. Our open terminal, so let's do npx create next app at latest --ts to add TypeScript --tailwind, which is the UI library we're going to use, and --eslit. Click enter. And we will need to name the project. It can be any project name. I will give it a name called Gemini demo. And I will select yes for the src directory, and we will need the app router, and we don't need to import alias. and then it will automatically start setting up the Next.js project. Once it's done, you can see this new folder created. So we'll do cd Gemini demo to get into that folder. And next, we will need to install a few different packages that we're going to use. I will do npm install AI. That is SDK provided by Verso, which made chat app and chat streaming a lot easier. And then we will need to install OpenAI to get access to all the OpenAI functionalities. And then we will also use silence aware recorder, which is audio recorder that can automatically detect if the user stopped talking, as well as use media recorder that can record the camera video, a package called merge image that can allow us to put multiple different images together into one image grill. So we click enter and it should start installed package automatically. Once it's done, you can see all those packages has been added to package.json already. So now this Next.js project has been set up already. You can do npm run dev, and you will see a page like this, which is the default page for any Next.js app. So now we need to start customizing and build out all those custom functionality that we need. And the way Next.js project structure is the main page will be under this page.tsx. But we don't need any of those. So I'll just remove everything and replace it with placeholder for now. And as you can see, the page should be automatically updated here as well. Next, we want to create a new file under app folder called chat.jsx. And this is where we will implement the main application. And we'll first give it use client so that it can use all the client functionality that we will build later. And then we'll import a few different libraries that we're going to use later. A few libraries from React that allow us to set a state, and also the use chat package from Verso AI that allow us to call OpenAI API and streaming the results, as well as a tool recorder that we mentioned before to record both camera, video, and voice, and merge image package that we will use to create an image grid. Then we'll define a few different configurations. One is interval, which is how often do we want to capture the screenshot from the camera image, and a few details about the image grid that we're going to create, the maximum amount of screenshots that we're going to send to OpenAI, and silent duration and silence threshold that will be used as a threshold to detect if the user stopped talking. Next, we will initiate a few different state and reference. Use reference is a functionality provided by React that allow us to easily refer to a specific DOM element, let's say the video element that we're going to manipulate and display image, or some value they will want to store and refer later. While state is not a functionality provided by React, they allow us to store the specific state of certain things. And every time when a state changes, it will re-render the application. But I will explain all of them later as we dive into details. Let's firstly add the video recorder. So I will do use media recorder, set video to be true and audio to be false, because for audio, we're going to use a silent detector recorder instead. And also adding two functionality, start recording, which will be triggered when the user click on a start session button to start record the video, and set a state, is the recording started, to be true. Also a stop recording function, which will be triggered when the user click on stop session. And then I will set a use effect. So use effect is another functionality provided by React. It's basically a function and rules that you define, which will be continuously monitored and triggered. So you can say if certain condition is met at any given time, then trigger a specific function. And in here, we will use this use effect to display the latest image captured by the camera. In the end, we will return the UI elements. So we have Canva and also a few div with a tailwind style and add a video component. So this should already set up a camera recorder and display the live camera on the page. And on the other hand, we also want to add a button for users to start or end the session. So we'll add a new div after this. If the recording session already started, it should display a button for stop session. But if the started state is false, then it should display a button for start session. And those two buttons should call the function for start recording or stop recording. So this chat component should already provide some basic functionality to show a video camera recorder. All we need to do now is go back to the page.tsx, import the chat component that we just did, replace this return to return the chat component instead. Click save. Now we go back to our Next.js app. We should have a little start session button. If I click on that, for the first time, it will ask you for the permission. Once you allow, you will have a web app like this that will automatically capture and streaming the video. And next is we want to also set up the audio recorder with the silence aware recorder. So I will create an audio object with use silent aware recorder. We will define a function here called onSpeech, which can be triggered when it receives new audio data. And here is where you can define the silence threshold and silence duration. That will be automatically handled by the silence aware recorder. And in the start recording function, I will also add the audio start recording too. And then we'll create this onSpeech function, which will be called if we detect that user stops speaking and send all those audio data. And inside this function, we are using a isBusy reference. So this is a reference that we create above here. We're basically use this to detect if we are waiting the response from OpenAI. Because if it is, then we should terminate this function right away. But if it's not, then we will need to set isBusy to be true, stop recording, and later send audio to Whisper for transcription. But for now, we'll just keep it simple like this. And then we'll set up new use effect. The purpose of this is basically dynamically set up the volume percentage, and we'll use it to dynamically updating the volume indicator in the UI based on the current volume level. So if the audio is not recording, just set the volume percentage to be 0. If the audio is actually recording, it will dynamically update the minimum and maximum volume reference and use that minimum and maximum number to set up a volume percentage number. After video element, add a new part. If the audio is actually recording, then we display the little UI that will dynamically change based on the volume percentage. But if the audio is not recording, then we will show a little stop icon and click save. So now it should be able to capture both audio and video. So if I go back to the page and click start session, you can see on the left side, there's a little UI component that will be automatically updating while I'm talking. But if I stop talking, it should turn back to a different icon. Here we go. So now we develop this application that can detect if the user stopped talking. After we detect the user stopped talking, we want to generate image grid to capture what has been happening for the past few seconds, and also using Whisper to automatically transcribe the voice into a text prompt. So we can send both the text prompt and image to GPT4V for you to get a response. And the first thing we're going to do is generate this image grid. So we'll need to move to top and define a few different functions. So our first is create a transparent pixel, which we will be using as a divider to generate image grid. And first function is get image dimensions based on the image source. And here you will see something called promise. So this is basically a way in JS to do things async. And next we will add a second function called base64 to blob. So this function basically converts the image data into a format that we can manipulate and send to server. It will be used in the next function we're going to define called upload image to free image host. So this basically will upload the image screenshots we take into a free image hosting service called temp files. So temp file is a free temporary file storage. We will get blob information from the image, upload it to temp file, and get a URL back. Last but not least, we will convert all those images into an image grid. So it will get all the images and also the number of columns with the image quality that we defined above here. We'll get the dimension of the image, calculate the aspect ratio, and calculate the number of rows that we should have. Prepare the image for the merging, and in the end, merge all the image together into one grid image. Those are all the functions that we need to generate the image grid. And then we will need to trigger those functions. So I will move down to the onSpeech function, which will be called when the user stops talking, and triggering that function. So firstly, we'll set a state phase to uploading video captures, which is defined by max screenshots we defined above. Then generate image grid and upload the image grid to the free hosting service, and set the state image grid URL to be the URL it returned. And in the end, set the state phase to be processing completion. And we will also need to add a new use effect to save screenshots every few frames. So we'll define capture frame here. If the video is actually recording, then we'll proceed to get the image with data we defined above, get the image data from the video recorder, push that new image to a screenshots reference. And we will also set an interval, which is how often this image should be captured. And that's pretty much it. All we need to do now is create debug button so that you can see the image grid is generated. So let's move down here. After the start stop session button we defined before, add a new button called debug. Once I click on this button, it should set a state display debug menu to be true, and add an overlay to display both the phase state as well as the image grid. And this div should only be displayed if display bug is true, and there should be a close button that will set display debug to be false. So that's pretty much it. Let's save it and go back to our web app. So I will start session and say something, then stop. And if I click on the debug menu, it should display the phase that processing completion as well as the image grid. So this is working well. The next step is we will also need to call Whisper to get a transcript to use as text prompt. To do that, we will need to create some function for speech to text first. And I will go to the app folder and create a new folder called API. Inside, I create another folder called speech to text. with a new file called route.ts. So route.ts is a type of file in Next.js 13 that allows us to have route handlers. If you don't know what a route handler is, it allows us to handle requests to specific route. For example, currently we are on localhost 3000/API/speech-to-text. And based on this front-end call, we want to do a post request to the specific route. For example, so I can simply create an export async function post request. This will be called when you try to do a post request to this specific route. And we can get the request body by doing const form data equal to await request.form data. And then you can get the specific value from the request body. And in this speech-to-text function, we will need 3 different params. One is audio file, so we'll do form data get file as file type, as well as token, which is the OpenAI API key that we're going to use for Whisper, and also language code, because Whisper supports more than just English, and you can pass on the language code to support all the other languages as well. If we don't have API key, then it should throw an arrow, no API key provided. But before we call Whisper, we actually need to import OpenAI library. So I'll move to top, import OpenAI from OpenAI. And we will also do export constant runtime equal to Edge. And Edge is part of Verso that provides optimal infrastructure for API route. If you want to learn more, you can click on this link. And then let's go down and create OpenAI object, passing on the API key. But here you can also do process.env.openAI API key to get environment variables. And to do that in Next.js, you can create a new file called .env.local and add an environment variable here, which should be able to access anywhere when you do process.env.openAI API key. But otherwise, we can also create a UI on the front end for users to put API key if you want to let other people use. And then we can pass on the audio recording to Whisper and return the generated transcription. On the other hand, as I mentioned before, that we want to also create an input for the user to type in their API key directly, and also the language. And we don't want users to type in the same API key again and again. So what we're going to do is I will go to the src source folder, create another folder here called library. Inside library folder, I will create one file called use local storage.ts. And create a function here that can actually save those variables from the user input to local storage and can be retrieved later. And then I'll go back to chat.jsx and import this use local storage that we just created and move down to chat function and set both API token and language here. And then move down to onSpeech function, which will be triggered when the user stops talking, or add a block that can send audio to Whisper for transcription, which looks something like this. So we'll firstly set a state phase to be processing speech to text so we can keep track. We'll get API token and language from the local storage if the user already put in something in. And then we'll do an API call where we'll pass on both the audio file, the API token, language user selected to the speech to text API endpoint we define in route.tx. And once it's finished, we will try to get the response. If there's any error, then we'll alert error. Otherwise, we'll set the state transcription to the response that we get from OpenAI Whisper. So that's pretty much it. Now we just need to create some UI control to allow people to put in the API key and select language, as well as display the transcript. So I'll come down here. After debug button, we can add 2 inputs, one for the OpenAI API key, which will set the token value when the input value change, and same for the language. And then we also want to display the generate transcript. So I'll move down here and insert the transcript. Now this app should be able to automatically generate image grade and also send the audio file to Whisper to generate a transcript. So let's try this. I'll save it, go back to web app. I can put in the OpenAI API key here and also give a language code if I need. And language code here will need to follow a specific format called ISO 6391, which looks something like this. But you can also keep it as empty as well. So I click on start session. I will see something and then stop. Hello world. Once this icon change, I can open the debug menu and you can see that it has a transcript. I will see something, then stop hello world, as well as the image grade. Perfect. Now all we need to do is just passing on both the generate image grade as well as transcript to GPT4V so that it can generate a response. And as I mentioned before, we'll use the Verso AI SDK, which makes chat completion and streaming the results extremely easy with the Next.js app. And the way Verso AI SDK works is that you will use this use chat utility, and we can define the route handler when this use chat is triggered in a special location on the API folder create a chat folder, and create a route.txt. So the function you define there will be called when use chat is used. So we're going to go back to Visual Studio Code, and under API folder, we'll create a new folder called chat. Inside, we'll create a file called route.js and put in those code. So we'll import OpenAI as well as OpenAI Stream and streaming text response from Verso AI SDK. We'll put a special prompt here. So the assistant should receive a series of screenshots from a user live video feed. This screenshot represents a sequential frame from the video, capturing distinct moments the assistant is to. The assistant will analyze these frames as a continuous video feed, answer user questions while focusing on direct and specific interpretation of visual content. And then define a list of different rules. So when the user asks a question, use spatial and temporal information from video screens. Response with brief, precise answer the user directly. And keep in mind that the grid of image will show the same object in a sequence of time. When asked about spatial questions, provide clear and specific information regarding the location and also passing on the language. So the assistant must speak in the same language that the user specified. And then we'll define the post request, which should be both the image grid and text transcript, the API token, and the language. And we're going to do the same thing, just call the OpenAI API key. And we're going to do the same thing called OpenAI with GPT4V and return the response. And in here, Verso AI has this special object called streaming text response, which will be able to stream back text response to reduce the latency. And then we'll go back to chat.jsx. So first thing, we need to go back to the onSpeech function and do this await append. And what this will do is it will add the image file as part of the message that we're going to pass on to OpenAI. And after that, we will call the use chat function where we pass on both the message, the append, which is a image that we just created above. And inside, we're also passing on extra param body, where the OpenAI will be able to get the API key as well as the language the user selected. And what this does is it will send a request to route.js we define here right away. And once it gets a response back, it can trigger a unfinished function. And then we'll call this use chat, passing on not only the message append, which is the image, but also an actual body that including the API key and also the language the user selected. So this should actually trigger a post request to the API endpoint that we define here that we'll call the OpenAI. But after we get a response back, we want to do two things. One is streaming the result on the screen so that user can see the results, and also send result to text-to-speech model OpenAI has so it can talk back. And to do that, we're going to do the same thing. We'll go to API folder, we'll create a new folder called text-to-speech, and inside we'll create a route.ts, where we'll define a post request API endpoint, which takes in both the text input as well as the API token. Then we'll do a request to the OpenAI text-to-speech model with a specific voice model that we choose, but you can change to others too. And we'll fetch audio data, convert it into block that we can set back to the front end. That's pretty much it. Now let's go back to chat.jsx. We'll add a unfinished function, which will be called when GPT4V generates response, and it will take the message it generated as input. So we'll set state phase to be processing text to speech. Again, we'll get the API token passing on to the API endpoint that we defined above. And once we get the audio response back, we will want to play this audio. So I'll move up and add a function here called play audio, which will take the URL of the audio file and start playing the audio. And that play audio function will be called here. And once we play the whole audio file, we can turn on the audio recording again to wait for user's next question and instruction, and set the state phase to be waiting for speech. And then we'll move down after the last use effect, set something to get the last assistant message so that we can display. And then we'll add a UI to actually display the assistant message. So after the video and audio recording div, I will add a new div. So this demo should be fully functional. We can start testing it out. So let's try this out. I'll go back to our web app and then start session. What am I holding on my hand? So you can see once I finish talking, it will have a loading state here.
You are holding a bottle with an orange cap.
What is behind me?
Behind you is a kitchen area with cabinets and a countertop.
Which path is safer for the little bird to go? Path 1 or path 2?
Path 1 is safer for the little bird to go as it avoids the cat. Path 2 leads directly to the cat, which could be dangerous for the bird.
What should be the next shape in this sequence?
The next shape in the sequence should be a hexagon.
Is this a hexagon you were talking about?
Yes, that's the hexagon I was referring to. It correctly follows the sequence by adding one side to each successive shape.
Which book is better for me to read if I want to learn AI?
If you want to learn about AI, The Coming Wave by Mustafa Suleyman would be the more appropriate choice. It seems to be focused on the future of AI and its implications, which would be relevant to your interests in artificial intelligence.
Which jacket should I wear for the Christmas party?
The blue jacket on your right hand would be more suitable for a Christmas party. It looks more formal and appropriate for such an occasion.
So this is a walkthrough about how can you recreate Gemini demo by yourself with GPT4V Whisper and text-to-speech model. And thanks again for Julian DeLuca for providing such a great example. Please comment below about other interesting multimodal applications that you are thinking about building. I'm really curious to learn more and do more experimentation. I'll continue posting interesting AI projects I'm doing. So if you enjoyed this video, please consider giving me a subscribe. Thank you, and I'll see you next time.